Making predictions from a regression model, interpreting and understanding. Hi, I'm Dr. Nick, and in this video I'm going to explain how you use a regression model to make predictions. This video is part of a group of videos about multiple regression models, including linear or simple regression. Check in the description below for more videos about multiple and simple regression. In this video, we will start with an example of predicting with simple regression, evaluating how good the prediction is. I will explain the problems of extrapolation. I then give an example of predicting with multiple regression, similarly evaluating it. At the end, I will touch on confidence intervals and prediction intervals for predictions. Simple or linear regression is where there is just one predictor variable. You can see more about this in the video Bivariate 2, example of bivariate investigation, and Bivariate 3, fitting a line. Waimarie's orange juice. Based on data from 20 oranges, Waimarie has developed a regression model to predict the amount of orange juice in an orange of a given weight. The model is juice equals 0.44 times whole minus 25. Using this model or formula, she finds that an orange that weighs 200 grams would be expected to yield 0.44 times 200 minus 25, which equals 63 grams of juice. The value, 63 grams, could also be read off the graph by drawing a line up from the 200 grams on the weight independent variable axis to where it meets the fitted line and across to 63 on the juice dependent variable axis. We do not expect every 200 gram orange to produce exactly that amount, as there will still be variation in yield between oranges. But on average, oranges that weigh 200 grams will give 63 grams of juice. Now let's predict the juice in a 230 gram orange. We use the model or formula and find that an orange that weighs 230 grams would be expected to yield 0.44 times 230 minus 25, which equals 76 grams of juice. This can be read off the graph by drawing a line up from 230 grams to where it meets the fitted line and across to 76 grams for the predicted amount of juice. Validity of the prediction. The validity of any prediction depends on several things. How typical the object is that we're predicting for. Is it in the range of the sample data? How strong the relationship is. How good the data is. Predicting for a value outside the range of the original data is not a really good idea, as we do not know if the data behaves the same outside that range. It could be that smaller oranges have the same proportion of juice, or it might level out, or they might have less. And larger oranges might behave differently also. The model might still be a good fit, but it could be that larger oranges are juicier, or the yield might level out. The point is that predicting outside the range of data comes with a warning. We need to be careful when predicting outside the range of the sample data. The model predicts best when the object is similar to the average in the sample. Predicting for an object outside the sample range is called extrapolation. Predicting for an object inside the sample range is called interpolation. I think we've covered that enough. When evaluating our prediction, we also look at how strong the relationship is in the model. We can tell that by looking at how close the dots are to the fitted line. When the dots are close to the line, this indicates a strong relationship. In simple regression, we can use the correlation coefficient, or R, to tell us how strong the relationship is. The correlation coefficient R for this set of data is 0.73. This means that this is quite a strong relationship. The predictions are likely to be quite good. I will discuss more about variability and the strength of a model in another video. And we also need to be aware of how good the data is. This orange data was taken from 20 similar oranges by the same person and weighed using the same equipment. The sample was not random for all oranges of this type, but this model is pretty much fit for purpose. So now let us predict using multiple regression involving more than one, in this case 2 predictor variables. We cannot show this easily on a graph, as we could with the simple regression. This example is around the price of a used car, specifically a Toyota Prius in New Zealand in January 2021. It was introduced in the video Multiple Regression and Overview. Demuth collected data on 50 Prius cars and used Excel Analysis Toolpack to find a regression model. It looks like this. Price equals 23,340 minus 1,028 age minus 25 distance. This model is like a formula to work out the average price for a Prius of a given age and with a given number of kilometres travelled. The variable price is the asking price in New Zealand dollars, the variable age is the age in years, and distance is the number of thousands of kilometres the car has on the odometer. Demuth's neighbour Luke has a Prius that is 8 years old and has travelled 120,000 kilometres. They want to know what a fair price might be if he were going to sell it. We put the figures into the formula and get 23,340 minus 1,028 times 8 minus 25 times 120. This comes to 12,116, which we will round to 12,000. This is probably a fair price for Luke's Prius. The value we get from the model is actually a prediction of the average price of Priuses which are 8 years old and have travelled 120,000 kilometres. It gives a ballpark figure. As before, the validity of the prediction relies on several things. How typical the object is that we are predicting for. Scatter plots are useful for studying ranges of values and relationships between the predictor variables in the sample data. This graph shows the distance travelled and the age for each of the cars in the sample. Luke's car at 8 years and 120,000 kilometres is right in the middle of the data. Luke's car has done a usual amount of kilometres for its age. Luke assures us his car is in average condition for its age. We can be confident that the predicted price is a good estimate. However, if the car was outside the range for either of the predictors, so too old, too new, too many kilometres, or an unusual combination, then this model would not be suitable. This model works best for cars similar to the ones in the sample. The sample has cars that are between 5 and 15 years old. The older cars have a wider spread of distance travelled. We would need to be wary of using a model from this data to predict a newish car, such as 5 years old, that had travelled a long distance, such as 400,000 kilometres. How strong the relationship is. In the video about strength, I explained the use of the multiple correlation and R-squared values. The R-squared value of 0.65 is quite high, so the relationship is fairly strong. We cannot plot the predictor variables and the model all on one graph. However, this graph shows us the relationship between the actual price of each car and the predicted price using the model. It shows that the model is quite strong. How good the data is. Bearing in mind this data was collected in New Zealand in January 2021, we would not expect the predictions to work for cars in different places or times, or different kinds of cars. The relationships could probably be generalised to other similar situations, but not the predictions. The data was collected from cars on TradeMe, which is probably a good representative sample of all cars for sale in New Zealand. If we had just got cars from one car yard or one city, it is less likely to be a representative sample. This next section is more advanced. Some statistical apps will calculate predictions for given inputs, with confidence intervals and prediction intervals. However, Excel does not do this, and these are difficult to calculate by hand. It may be helpful to know how to interpret the different intervals. The confidence interval gives the range within which we are 95% confident that the actual value for the mean of that kind of car will lie. The prediction interval, which is considerably larger, gives the range within which the price of 95% of the actual cars of that kind in the population will lie. These intervals are outside the scope of many courses, but it is useful to know if you're wanting to use regression to predict. This video has been about predicting using a regression model and is one of several videos about multiple regression. Please like this video, subscribe, but most of all join the channel, especially if you're using our videos in your teaching. Help the channel grow and help me help more and more people like you. Joining the channel also gives you access to more helpful videos like these. I am truly grateful for my channel members who help make these videos possible.